Next we discuss about Pascal's principle. When pressure is applied at a point in a confined fluid. See these examples. If you press a balloon at a point, then what happens? It bulges out at some other point. Similarly, if you press this, you are applying pressure at this point, but this pressure will transmit it to these points, as I was saying in the figure. This example shows that a liquid can transmit pressure. Pascal summarized this in a statement called Pascal's law. According to Pascal's law, pressure applied anyway in a confined fluid is transmitted equally and undiminished in all directions throughout the fluid. Consider this example. This vessel is filled with water and is having 4 identical watertight pistons P, Q, R, S. Let some force applied to the piston P, which moves inward. The remaining 3 pistons are found to move outwards. If you want to prevent them from moving out, the same force has to be applied to each one of them. This clearly shows that pressure applied at one point has been transmitted equally and undiminished in all directions. This is Pascal's law. Now we take some applications related to Pascal's law. The working of hydraulic machines such as hydraulic press, hydraulic jack, hydraulic brakes are based on Pascal's principle. The principle of hydraulic machines, hydraulic lift. This lift contains 2 cylindrical vessels, as I was saying in the figure, and these 2 are connected with a horizontal tube. These 2 vessels are filled with water or any other liquid and fixed with 8 pistons M and N respectively. Let A1 and A2 be the area of cross sections of the 2 pistons respectively, such that A2 greater than A1. If a weight is kept on piston M, this exerts some force on it. Here the force is acting on area A1, therefore the pressure is P1 equal to F1 by A1. According to Pascal's law, this pressure is transmitted equally and undiminished throughout the liquid. Hence, the pressure acting on this piston is in upward direction and the piston moves up due to this pressure. To prevent it from moving up, a force should be applied to it in downward direction by putting certain weight on it. If we consider, let F2 is the force at this piston. This is equal to pressure on this piston into area of cross section. Now F2 equal to P1 into A2, or this is equal to F1 by A1 into A2. Since A2 greater than A1, F2 greater than F1. Thus, a small thrust applied to the smaller piston can be used to exert a large thrust on bigger piston. For example, we consider the ratio of area of cross section of these 2 pistons is 1:50. That means the area of cross section of this is 50 times more compared to the smaller one. When a force 1 Newton is applied, what is the pressure? Let us consider the area of cross section is 1 meter square and here it is 50 meters square. In this case, the pressure is F by A, that is 1 by 1. This is equal to 1 Newton per meter square. The same pressure exerts on this piston, 1 Pascal pressure or 1 Newton per meter square pressure exerts on this piston, and in this case the force is nothing but pressure into area. This is equal to 1 into 50. This is equal to 50 Newton. Here we are applying a small force, that is 1 Newton force, but we are able to produce 50 Newton force here. This is one of the application of Pascal's law. Using this principle, a heavy weight can be lifted using a small force. And another example of hydraulic machine is Brahma's press. This is called hydraulic press. It also works based on Pascal's law. And the uses of this press is for pressing books, cotton bales, etc., for squeezing the oil out of the oil seeds, for punching holes in metals, for extracting juice of sugarcane, sugar beet, etc. And another application of Pascal's law is hydraulic brakes. Hydraulic brakes are also works on Pascal's law. To stop a heavy vehicle moving with high velocity, a large force has to be applied. This is possible with hydraulic brakes. And these brakes works on the principle of Pascal's law. Say this. This is a model related to an hydraulic brake. This is brake pedal, brake levers. This is brake oil. This is called master cylinder. And these are connected to brake cylinder. And this brake cylinder with pistons are connected to brake shoes with some restoring spring. When you apply some force at this point, some pressure is applied at this point. The pressure is equally distributed. Due to this pressure, this piston will move. Brake shoe apply brakes on the wheel. The spring, that is restoring spring, helps the brake shoes to come back when you remove the applied force. This is working of hydraulic brakes.